Okay, 7.8, graphing square root and, well, we're not going to do the rest. So you can just cross out the other radical functions. That would be like a cubed root or a fourth root. We're not going to deal with that. If you ever need to graph those, you're welcome to use Desmos or another graphing software. But starting off with square roots, right? All of them are going to have some kind of root. They might have a number out front. You normally say x minus a under the root, and then we have a plus b at the end. So let's look at Desmos and let's see what this does. So right here at the top in the upper left corner, I have y equals c root x minus a and then plus b. And let's see, what does c do? Let me see. So c stretches and shrinks it, right? The only c's that we're going to care a lot about are the positive one, which is like right there. That's like the default. And then negative one, which is just going to be the negative version of it, the one below the axis, all right? So those are the only two that we're going to really care about. So if you're the number in front of your root, let me go back here. C stretches or shrinks. And then if C is less than 0, we reflect it over the axis, or we'll just say it's below x-axis, all right? And again, you're only going to care about c equals 1 and c equals -1 for our homework. All right, let's look at a, and we'll see what a does. So I'm going to notice that a, it's root x minus a under your root. And let me press play on the a. So as a gets smaller, it moves left, and as a gets bigger, it moves right. Right? So this is going to be our shift, left and right. Right? So let's go here. A is, we'll say left. A is the left-right shift. Notice that it's x minus a, right? So if you have something like root x plus 1, that means left 1. It's the opposite of what you think it should be, right? And I believe that's the same way as whenever we had a parabola and we'd have something inside of it squared, like x plus 1, that'd be a left shift. It's similar idea here. All right, lastly, let's look at B, and I think you could probably guess what B is going to do. B is going to move it down and up, right? And just because I want to, I think it looks really cool whenever you press play on all these, so isn't that neat? All right. So let's go back to the other page and we'll say B shifts it up or down. B shifts up or down. Okay. Remember the root function is like the reflection of a parabola, right? So it kind of follows that A and B could give you your kind of vertex, right? It's like the vertex, but we wouldn't call it a vertex. Yeah. So let's look at graphing. So here we have number 1, root x plus 3, and then plus 4. So the x plus 3 gives me a left shift, so left 3. The plus 4 gives me an up 4. So now that I have that written, I can draw my graph, and we'll draw our graph here. And I'm going to count tally marks, left 3, 1, 2, 3, up 4, 1, 2, 3, 4. So my first point goes right there. Like a parabola, you can go up 1 over 1, and then after that, we're just going to let it be. So it's just going to be like that, right? If you remember, the parabola then would go up 3 and over 1, so this one would go up 1 and over 3. So you can do both of those points if you so choose. All right. This one, again, did not have any stretching or shrinking because there was nothing in front of the root. Or rather, there was a 1 in front of the root. All right, next up. This one, we have a negative in front of the root. So that means it's going to be facing down, or it's going to be going down. And then, so the x minus 2 is going to mean right 2. The plus 1 means up 1. So drawing our graph again, I'm going to go right and up. So I'll do something like that. So right 2, 1, 2, up 1. There's my start. I'll go down 1 and over 1, and I'll go down 1 and over 3. And there we are. There's our root function. And again, I went down because we had that negative in front of our y. Or excuse me, in front of our x. Good grief, in front of your root, All right, next up. This one doesn't have anything in front of the root. See, I got first time that time. The x plus 1 means left 1. The negative 3 means down 3. So I draw my terrible graph. I'm going to be going left and down, so I'll do something like that. Left 1, down 3. There's my first point. That would be like my pseudo vertex, right? If it was a parabola, we'd call that our vertex. There's no stretching or shrinking, and we're going up, so it'll be up 1 over 1, and then up 1 and over 3. So just like that. All right, that's graphing. All of the graphing will be some version of this. You can either find some graph paper and do it on that, or you can just draw the graphs on your lined paper. I really don't care. Whatever works best for you. Next up, you're going to have some problems that say solve by graphing, right? And they're going to be kind of ugly like these that are kind of difficult to graph. So what I suggest and what I'm telling you to do is to find a online grapher and graph both of them separately and then see where they cross, right? If we were to find one way to solve like a linear equation, right? If we had like y equals 2x plus 3 and y equals 5x minus 6. If the problem asked to solve those equations, it's really asking where do they cross. So one way to do that would be to graph them together, right? Both on the same plane and just see where they cross. That's what this is saying. We have like y equals root 3x minus 5 and y equals root 10 minus x, right? It's two separate equations and we're solving it by graphing. So on Desmos, and I'm going to go to that in just a second, I'm going to graph this first piece, and I'm going to graph the second piece, and I'm going to see where they cross, right? The bottom one, I'm going to graph this, and I'm going to graph y equals 9, and I'm going to see where they cross, right? We are able to do these by hand now, and that works. But I'd like to show us how to do them by graphing. I highly suggest getting the Desmos app on your phone. They have two of them. They have the grapher and they have the scientific calculator one. I think they're both great apps. I use them on my iPad and I use them on my phone. So let's look at the grapher. So our first problem has both of these. So we have root 3x minus 5, that's the black one, and then root 10 minus x, which is the red one. And if you're on Desmos, you can just kind of touch one of them, and there we are. That's where they cross. That is the answer to that problem, right? You can write that down, or you can just, I'm not going to write that down, right? So this is why I think Desmos is so cool, because it auto gives you where they cross. All right, so we should have done, I think that was number 4. I'll hide both of those, and now I'll show these. So I have y equals 9, which is the green bar. And then I have root x plus 6, which is the blue one. And I zoom out just by pinching the screen. And I know it touches somewhere over here, so I just touch, and there it is. The answer is 75, 9. Or I guess it would just be 75. All right. So that's that. Let me know if you have any questions on these. I highly suggest getting the Desmos app right there at the top. You can see how to spell that. I think it does really well. If you're on a Chromebook or a laptop, the Wolfram Alpha website normally does a really good job also. It's much more of a like search bar where you type in the question and it'll spit out an answer for you. But Desmos is pretty great. In class, I will show you how to use a graphing calculator to do this. So, all right, that's all.